Hello everyone, welcome to my channel, The Big Boolean Theory. This video is part of a lecture series on operating systems, and currently we are on the second module of this course, that is process management. The idea behind this module is to give you a basic understanding of how the operating system manages the CPU by providing this abstraction of a process. So within the second module, currently we are on the first topic, that is process introduction. And here we are trying to understand what exactly is a process and how does the operating system implement this abstraction of a process over the CPU. So in the previous few videos, we have understood what is a process and also talked about the concept of a program. Now, the point is that if you talk about a program, then you very precisely know what you're talking about. It's a binary file that contains the instructions and data. But if you talk about a process, then it could mean a whole bunch of things. Do we mean the instructions that are getting executed on the CPU, or do we mean the code and data that are sitting on the memory? So there are many things that are associated with a process. When we say a running program, a whole bunch of things are going on. So we do not have a very precise or explicit way of saying what exactly is a process. We can say it's a running program, but it could mean a whole bunch of things. So we need a very clear way of representing a process, and that is what we are going to see in this video, that how the operating system represents a process, and it does that via something known as process control block. So let's see how the operating system represents a process and what is a process control block. So let us start the discussion with this time sharing diagram. And what this time sharing diagram is trying to convey is that the operating system has to first of all share the CPU between all the processes that are there in the system, right? There is a computer system and there are several programs that want to run on the CPU, and all of these running programs are modeled as processes, and it's the responsibility of the operating system to share the CPU between all these three processes. Now, the very first thing that the operating system must do is that it has to be aware of all the different processes that are there in the system. It must have a way in which it can properly keep track of all the processes that are there in the system. So in this figure, you can see there are three processes, P1, P2, P3. Only when the operating system has a way to keep track of all the three processes, then only it can perform this time sharing. And time sharing is very crucial for making the CPU easy to use, right? So we have already studied these things, but my point is that we need a way to properly keep track of the processes. Now, you might ask that what is the problem with keeping track of processes? Why are we stressing on this fact so much? So let me ask you a question. So when I say, what do you think of when you think of a program? The answer will be very precise. Is that when we say a program, we mean that a binary file that contains instructions and data for a given program, right? You have written a code, and when you compile that, you get a binary file with the instructions and data for that code. That's it, right? The idea of a program is very explicit and very clear. There is no ambiguity when we talk about a program. But let me ask you the same question for a process. What does come into your mind when you think of a process, right? A process is a running program. We know the definition very well, but how do you describe a process? What exactly is the image that comes to in your mind when you think of a running program? There are a whole bunch of activities that is going on when you think of a running program. If you talk about the CPU, then the CPU is executing the instructions for that running program, right? Then if you talk about the memory has the address space, and in the address space resides the code and data for that process, right? So if you talk about the disk, then there are several files, and the running program might be interacting with the files. It might be creating, reading, or writing with these files. And finally, about the IO devices, a running program also interacts with the IO devices, right? It has to interact with the user to get the input and display or send whatever output it has produced. So you see, a running program interacts with all of the hardware resources that are there in the system, and thus there are a whole bunch of activities that are going on when you think of a running program. So the question now arises that what exactly is then a process? How do you describe a process precisely? There is no concrete way of describing a process. There are a whole bunch of ways in which you can describe a process, right? For a program, it was very simple. It meant only one single thing, that is just a file, a binary file with the instructions and data. But for a process, there are a whole bunch of different activities in which we can describe a process. So then the problem is, how does the operating system keep track of the process, right? Unless it is able to keep track of the process, it won't be able to do the time sharing of the CPU. So that is why we need a very concrete and explicit way, so that the operating system is able to represent the process, keep track of them, because it is necessary for managing the CPU. So now let us see, how does the operating system represent a process in the computer system when we have so many different ways of describing a process, right? So let's see how the representation of a process works. So in order to keep track of a process or represent a process, what the operating system does is that whatever piece of information is important, is relevant from the perspective of the operating system in the context of a process, it stores all of that information. So before we see how the operating system stores the relevant pieces of information, first let's talk about what are the different pieces of information that is relevant in term of in the context of a process. So a process is a running program, and when a program is running, it will be using the different hardware resources of the system, and its interaction with the different hardware resources is what is important. So as you can see from this figure, I have listed down the different relevant pieces of information in the context of a process, and it is mostly related to the different pieces of computer hardware with which the running program or the process interacts with. So let's go over each piece of information one by one and see what is relevant with respect to the interaction between a running program and that particular piece of hardware. So let's start with the CPU. So in the context of the CPU, the CPU is where the program is being executed, and there are several registers in the CPU which store the data and instructions for the running program. So you can say the contents of the registers keep changing as the program is being executed, and the contents of the registers, that is the instructions and data, give you an idea of the execution, where the execution is, right? So it is very important from the perspective of the operating system to keep track of these CPU registers. So this was about the CPU. Now let's talk about the memory. So memory is where the code and data for that process will be living when it is being executed, right? And we have already seen that within the memory there is the process address space, and within the address space the operating system organizes the code and the data of the process in a certain way, right? And this address space is something which is very important from the perspective of the operating system. The operating system needs to keep track of the address space that is related to the process. Just like in the case of the CPU, the state of the CPU registers were important. In the same way, if you talk about the memory, the process address space, the code and data of the process is important from the perspective of the operating system. Now let's move on to the disk. So the disk contain the files, and when a program is executing, it might be interacting with different files. It will be reading or writing those files, creating or deleting those files, right? So when the process is interacting with the disk, the persistent storage, right? So these files are important from the perspective of the operating system. So the operating system will keep track of all the files which the process is reading or writing, right? So the list of all the open files is something which is a relevant and important piece of information with respect to a process, right? Then let's talk about the IO devices. So IO devices are required by the running program for interacting with the user. The user provides their input via the input devices, and whatever data or output that the process produces, that is sent to the output devices for the consumption of the user. So there might be several IO devices with which the process will be interacting during its lifetime. So from the perspective of the operating system, keeping track of all the IO devices with which the process interacts with is also important, right? So this was about the different pieces of hardware, how the running program interacts with them, and what is the relevant piece of information that the operating system must store with respect to that particular piece of hardware, right, for that process. So finally, let's talk about the metadata part. So there are several important pieces of information that is associated with the process itself. For example, there is the process ID. Every process is assigned a unique identifier so that the operating system can uniquely identify that particular process. Apart from the process ID, we can have the state of the process. A process can be in a running state, it can be in a waiting state. So there are different states which we will talk about that are associated with the process, right? It could be in a terminated state. So apart from this, there are other pieces of data. For example, the priority of the process. Some processes have more priority when we talk about sharing the CPU, right? So which process should the CPU be assigned to? So there are certain processes which have higher priority, and keeping track of the priority is also important. So priority is another useful piece of information. So there are also some other pieces of accounting information. For example, for how much time the process has been running, how much CPU it has used. All of these pieces of information come in the metadata part. So these are pieces of information that are associated directly with the process. So you can see there are several important pieces of information that are related to a process, and all of these pieces of information are something that the operating system must take into account. So whenever we want to represent a process, that's the whole point, right? We want to represent a process. So the way in which the operating system will represent a process is that since there are a bunch of different things that are going on when a program is running, the operating system will keep track of all the relevant pieces of information that are useful and that are necessary in the context of the process. So till now we have talked about what are the different pieces of information with respect to a process. Now let's see how the operating system will use those information, will store this information to represent the process. So now we have a basic idea of how the operating system will be representing a process. So basically there are two parts to representing a process. The first part is identifying what are the important or relevant pieces of information. And once this identification is done, then the second part is figuring out a way of how can we store all of these important pieces of information. And once you have that, then you can say that you have successfully represented a process. So in the previous slide, we talked about what are the important pieces of information that are related to a process. So these are the information that is listed here: CPU registers, memory, IO devices, files, and some other data. All of these are important with respect to a process. A process is a running program which interacts with several hardware resources, and we have to identify what are the important pieces of information in the context of that interaction. So that are all those important pieces of information have been listed down here. So this is the first part, that is identifying what is important with respect to a process. Once we have identified this, we have to store all of this in a place, and that place is called process control block. So what is a process control block? A process control block is a data structure, right? It's a place where we store data. And what is the data that we store? All of these important pieces of information that we identified in the first step, these pieces of information that describe a process, all of these are stored in one data structure, and this data structure is called process control block. So now you can understand that the process control block is a data structure that represents a process, right? So let's now look at how does the process control block actually looks like. So you can actually use any kind of data structure that suits your need. So most operating system use a C style structure in order to represent a process. So we know what is a structure. A structure is a collection of different fields, and each of these fields can have a different data type, right? And since we have already identified what are the different pieces of information that are important to a process, we can just have those pieces of information as different fields in this structure. So you can use some other data structure also, but most of the operating system uses a C style structure. So now you have a basic idea of what is a process control block. So the definition of process control block is that it is a data structure which is used to represent a process. It is a collection of information related to different pieces of the system that the process accesses or affects during its execution. Let me go over this once again. So there is a program, it is running, it is executing, and there are different pieces of the system, different hardware resources that it will be accessing, or you can say interacting with it, and in a way affecting those hardware resources. So the operating system has to store the information that is in the context of this interaction with the hardware resources, and all of these information it collects into one place, and that is called the process control block. So now we know how can we represent a process. A process is an abstract entity, right? It has a whole bunch of different things that is associated with it. So if you want to concretely represent a process, then you just collect all the relevant pieces of information related to the process and store it in one single data structure. That data structure is called the process control block. So in order to explain you the concept of process control block in more detail, I have an example from a real operating system. It's called XV6. So this is the process control block and how it looks like in the XV6 operating system. So what is XV6 operating system? It's a toy operating system that has been designed in the MIT University, right? So this toy operating system, they use it to teach operating system at MIT. And I have attached the link of this code repo for this XV6 in the description box. I highly recommend that all of you please go and have a look at this XV6. It's just 30 files, and there is a very proper documentation associated with this code repo. And if you are able to understand this small tiny operating system, then you will have a real understanding of how the operating system looks like and how does it work, right? So here, as you can see, this is the process control block from a real operating system, although it's a toy operating system, but nonetheless it's a fully functional operating system, right? So let's go over the different fields in this structure. So this structure has been named proc, right? It represents a process, and as it says, it's a per process state. So for every process in the system, there will be multiple processes in the computer. For every process, there is a process control block, and a process control block is a data structure, and in this case it's a C style structure. So I won't go into the details of all the fields because we don't have enough context to understand all of the fields, but let's look briefly at the ones that we can understand. So first of all, there is the process ID, right? For every process, there is a unique identifier. It's an integer Using this integer, the operating system can uniquely identify that particular process. So this is a type of metadata. Then you can say there is a state. So with every piece of for every process there is a state. A process can be in different states. It could be running, it could be in a waiting state, it could be terminated, right? So all of these is captured in this state information. So this is again a metadata. Now let's look at the context. So context will be a collection of CPU registers. So although this struct context has not been described here properly, but context is a collection of CPU registers, and whenever one process switches to another, that is the control of the CPU switches from one process to another, then all of these CPU registers is stored in this context, right? So that is why it's also known as a context switch. When we switch from one process to another, right, then all of the registers in the CPU are swapped from one process to that of the another, right? So this was about the CPU process. Then you can see this is struct file. This is the list of all the open files. So this is related to the files. So a process will be interacting with different files when it is executing. So the information related to all the files is stored here, right? Then there is a name of the process. This is human readable name. That is the name of the executable that you launched. So this is again a metadata. Then there is something called page table. So we don't really know what exactly is page table at this point, but think of this page table as a collection of virtual addresses to physical addresses mapping. So we have already studied the concept of an address space in the earlier video. We said that for every process there is a unique virtual address space that is mapped to the physical address space. So this page table contains those mappings, and in a way it describes the address space. So all of the information that is necessary to describe the memory of a process, that process address space information is contained in this page table. Then there is the size of the process, that is the total amount of memory that this process is consuming, and other pieces of information. I feel you can understand the current working directory. So within the disk, in which directory the process is currently executing, that is also important. So in a way, if you see, the context is related to the CPU registers, the page table is related to the memory. Then if you think the files is related to the disk, the current working directory is also related to the disk, and rest of the pieces you can consider as different pieces of metadata. Another thing is that what will be the exact fields and the exact pieces of information in a process control block is very specific to the particular operating system. Since this is a toy operating system, there are very less fields in this process control block. If we consider a fully functional industrial operating system like Linux and Windows, then they provide much more functionalities compared to this toy operating system. So industrial operating systems, the process control blocks of those operating system will have much more fields. So my point is that the amount of information that you want to store for every process is dependent on the number of features that you want to provide to the user. If an operating system has to provide much more features, then it has to store more amount of information for the particular process. So the process control block is very operating system specific. So now that we have a basic idea of what is a process control block, I want to discuss a few important points about a few other important points about the process control block or the PCB. So as this slide says, for every process, the operating system creates a process control block. So this is quite obvious, right? We have to represent all the processes in the system if we have to perform the time sharing of the CPU between all the processes. So for every process, there will be a unique PCB. So as you can see, if there are n processes in my system, then for every process, there will be a unique PCB describing or representing that particular process. Using these structures, the operating system keeps track of all the processes in the system, right? So this is the first point. The next point is that all of these structures are generally part of a list that is called the process list. So this process list, as you can see, it's a collection of all the PCBs or process control blocks in the system. And using this list, using this process list, the operating system has a very clear idea of what are all the different processes in the system, what is the specific information with respect to each process. And that is how the operating system keeps track of all the processes in the system so that it can share the CPU between the different processes. So the next point is that finally you should not confuse the process control block with the process. A process control block is just a metadata, not the metadata. You can say it's a data structure that represents a process. It is not the process. A process is an activity. It's an abstract thing. We are trying to kind of represent it in an explicit way. Nonetheless, the process is very different from the process control block. The process is an activity that is going on. It's an abstract thing, and since we want to be more concrete, that is why we are trying to describe the process in different ways. And in the way of describing the process, we collected different pieces of information that was necessary for that process and brought all of that into one single place. That is the process control block. So you should not confuse the process control block with the process. The process is an activity, it's an abstract thing. The process control block is a data structure. So now that we have a good understanding of how the operating system can represent a process in the computer, let us now see how the operating system can use the process control block to perform the time sharing. So if you recall, in the beginning of this video, I said that the operating system needs to be able to keep track of all the processes. It has to represent all the processes so that it is able to properly time share the CPU among the different processes. So now that we know how the operating system can represent the processes with a process control block, let's take a small hypothetical example and see how the operating system uses these PCBs, right? So here I have a very simple computer, a simple hypothetical example. So you can see there is a single CPU in the system and there are two processes, right? There is the first process with process ID 100 and there is another process with process ID 200. So these are the two processes in our computer system. And as we know, for every process, the operating system will have a process control block to represent that particular process. So you can see there is this PCB for this process. You can see the process ID 100 and similarly, this is the PCB for this process, right? So the point is that for every process, the operating system creates such process control blocks and it has all the relevant pieces of information which the operating system needs to keep track of the process. Here I have only shown the process ID, but you know that there will be much more pieces of information stored in the process control block. So now let's see how the time sharing will take place. So there is a single CPU and there are two processes. So let's say the operating system decides to allocate the CPU to process 100. So what the operating system does is that it allocates the CPU to this process and in the meanwhile, it will be pointing to this process control block. So this process control block that is for process 100 stores all the relevant pieces of information, the state of the process and everything that the operating system needs to know about the process 100 is stored in this, right? So let's say now the operating system decides to take the control of the CPU from process 100. So as you can see, the control has been taken away and now it has to make a switch to a different process. So as we know, the CPU registers, the CPU is executing the instructions of the program, right? The CPU registers change as the execution proceeds. The data and the instructions are stored in the registers. So now that we have to switch from one process to another, that state that is present in the CPU registers. So as the execution proceeds, the registers build some amount of state. Right, by state I mean the current values of the registers. So those values have to be stored somewhere because now we are pausing process 100 and at some later point in time we might have to resume the process, right? So it's not finished, it's just being paused. So we have to store the CPU registers, take a snapshot of those registers and store it somewhere. Where will we store it? We'll store it in the place, the one single place that is being used to store all the relevant or important pieces of information that is related to that particular process. So all of those CPU registers will be saved into this process control block. So this is just one example how we can use the process control block. There could be many other use cases, right? I'm just talking about the CPU registers to just give you an example. Now, after the CPU registers have been saved in the process control block, now the operating system can bring in some other process to start and executing. So here this is process 200 and the operating system can decide to give the CPU to this process. So when we allocate the CPU to this process, then all of the registers that are part of the process control block that is 200, that will be restored into the CPU, right? So so process 200 can start or resume execution from that point. So the CPU registers contain the state of the execution and we are assuming here that process 200 had run already at some point in time and we are just restoring that state into the CPU. So this is how the operating system performs the time sharing. First of all, it keeps track of all the processes in the system by having these process control blocks. These process control blocks are the storehouse or storage place for all the relevant pieces of information that is related to a process, and the operating system can use these process control blocks to implement time sharing, or for that matter to do some other tasks in the operating system related to the process. So guys, this was it for this video. In this video, we understood how the operating system can represent a process by storing all the relevant pieces of information in a single place. We talked about what are the relevant pieces of information like CPU registers, address space, files or information related to IO devices or some important metadata. All of these important pieces of information the operating system identifies and stores it in a data structure. It is known as the process control block. So guys, this was it for this video. Thank you very much for watching, and I will see you in the next video. Thank you.